1998, National Archives 2, College Park, Maryland. The air in the special research room was dry, cold, and smelled of decaying paper and microfiche solvent. A perfect environment for burying secrets. Dr. Elias Thorne, a retired professor of aviation history, adjusted his reading glasses. For 3 decades, he had chased the statistical anomaly of the Lockheed P-38 Lightning, specifically the unexplained jump in its operational combat radius in mid-1944. It was too sudden, too massive for a standard incremental upgrade. It was a single, dramatic correction. He was deep inside Box 113, marked V Fighter Command, Miscellaneous Engine Maintenance Reports, Standard Issue Bureaucratic Purgatory. Thorne was looking at a document, Memo 34B, dated June 1944. It was a 3-page internal report from a provisional 5th Air Force Service Depot in New Guinea. The text was mostly boilerplate supply requisitions, but on the 3rd page, a single paragraph had been manually added, typed in a different font, possibly days later. The language was clinical, almost poetic in its cold caution. Unforeseen data derived from applied field methodology now indicates a demonstrable and sustainable increase in operational flight envelope. Recommend immediate, though unapproved, dissemination of revised power settings. Fuel consumption rate now achieves a figure previously calculated as non-viable for sustained flight operations. Referencing Civilian Consultant File, CC 407. Thorne felt the familiar, cold prickle of a true historical find. He checked the document's authenticity. Genuine. But the next line was a wall. Consultant File, CC 407 status. Permanently closed. All hard copies redacted. He lowered the memo onto the desk, its fragility a stark contrast to the strength of the lie it contained. They hadn't just rejected the data. They had buried the source. A civilian consultant had done something so crucial, so impossible, that the USAAF leadership had stamped the file permanently closed and redacted every mention. Not for security, but for something more dangerous. For shame. Thorne pulled out a magnifying glass and examined the redacted stamp. It wasn't a standard official military classification. It was a custom-made rubber stamp, heavy and hastily applied. The ink bled slightly around the edges. A cover-up? Yes, but one executed by a single, determined man, not the entire bureaucracy. He looked up at the clock. Time was running out before the archive closed. He took a digital photograph of the memo. He knew, instinctively, that CC 407 was the key. He was no longer chasing a technical anomaly. He was hunting a ghost with a secret that had fundamentally changed the war, and whose existence someone, somewhere, had decided was an institutional threat. The P-38 was supposed to be a flawed, short-legged fighter. The official narrative was clear. Yet, in late 1944, it had begun appearing in skies it should never have been able to reach. An untouchable fighter, striking from impossible distances. Thorne now had the first word of the truth. It was the work of a civilian they had tried to erase. The military had hidden the most critical performance upgrade of the P-38 not behind a security wall, but behind a lie of convenience. The deeper truth, Thorne realized, was often the simplest. Engineers once called it impossible. 1943, Lockheed Plant B-1, Burbank, California. The roar of Allison V-1710 engines undergoing bench tests was the soundtrack to the war effort, a chaotic symphony of power and imminent disaster. This was the fortress where the P-38 Lightning was born, and where, just as frequently, its reputation died. The aircraft was fast, powerful, and deadly, but it was haunted by one ghost, its range. The problem, as dictated by every slide rule and engineering manual, was heat. Enter the civilian consultant, the man referenced in the redacted file. Elijah Vance. He was not a traditional aerospace engineer. He was a refugee from the world of pre-war dirt track racing and high-altitude endurance flight. His expertise wasn't in aerodynamics. It was in the intimate, brutal language of internal combustion. He understood that a piston engine wasn't a machine, but a temperamental chemical furnace. Vance was a disruptive presence at Lockheed. While company engineers sweated over structural stresses and supercharger efficiency, Vance spent his days hunched over thermal sensor readings, treating the Allison V-1710 engine not as a source of thrust, but as a source of wasted energy. His desk was piled not with blueprints, but with charts mapping exhaust gas temperature, EGT, against fuel flow. He saw the inherent flaw in the military's rigid operational doctrine. Every pilot was trained to avoid the so-called over-square configuration, running the engine at high manifold pressure, the force pushing air, fuel into the cylinders, while keeping the propeller RPM, the engine speed, low. The conventional wisdom, pounded into every pilot's skull, was simple. Over square equals detonation. The excessive pressure, combined with low cooling airflow from the slower RPM, would cause cylinder head temperatures to spike, the fuel to ignite prematurely, and the engine to tear itself apart. "It's a dogma," Vance muttered in his journal, archived decades later by Thorne's cold gaze. A superstition based on faulty test data and fear of complexity. Vance believed the conventional cruise setting, high RPM, TWI 200, 2400, and rich mixture, was nothing more than a crude, wasteful cooling mechanism. The excess fuel running through the engine simply dumped heat, keeping the cylinders safe, but pouring precious gallons into the Pacific Ocean. His proposal to Lockheed management was dismissed with contempt. To achieve maximum range, he argued, pilots must deliberately operate the P-38 in the forbidden over-square zone, reducing RPM to 2600 and increasing manifold pressure to 30 inches, all while running the mixture aggressively lean. This would produce the same power stroke with fewer, more efficient explosions, but it came with a thermodynamic catch. It bordered on the edge of the engine's death zone. A senior Lockheed engineer, a major named Hollis, once walked into Vance's makeshift workshop. He saw Vance's proposed settings scrawled on a whiteboard. "Vance, that's engine sabotage," Hollis said, his voice flat with professional disgust. "Those settings are a guaranteed engine failure inside an hour. We can't authorize a death sentence on a $120,000 aircraft." Vance didn't look up from his EGT charts. "You're thinking like a manufacturer, Major. You prioritize longevity. I prioritize distance. There is a thermodynamic sweet spot, a perfect balance of pressure and flow, that military training has trained pilots to fear." Vance's work was now entirely unofficial. He knew the USAAF would never change doctrine based on a civilian's theoretical charts. The only path left was to prove his heresy in the air, risking not just a catastrophic engine loss, but his freedom. The man who would save the P-38 had to become a pariah first. He needed a plane, a pilot, and the darkest stretch of sky he could find. 1943, night. A remote, unpaved auxiliary strip near the edge of the Mojave Desert. The air was thin and frigid, perfect for exposing an engine's cooling limits. The P-38J, serial number 426789, sat under the pale, indifferent light of a half moon. It was unofficially borrowed from the Lockheed test fleet, its logs falsified. Elijah Vance, CC-407, was buckled into the cramped cockpit, his face illuminated by the green glow of the instrument panel. Beside him sat a single young Lockheed test pilot, Lieutenant Dale Ranson, who had volunteered less out of conviction and more out of the boredom of desert postings. Ranson knew the risk. This was not a standard test flight. This was mutiny by manifold pressure. Vance leaned forward, his voice a low, urgent static over the intercom. "Listen to the engine, Dale. Forget the manual. Forget the noise. We are not looking for speed. We are looking for longevity at the edge of destruction." Ranson pushed the twin throttles forward. The Allison V-1710 engines, the temperamental heart of the Lightning, roared to life. Takeoff was normal, full RPM, rich mixture. They climbed rapidly, dumping the nose over the empty desert floor to begin the experiment. Vance watched Ranson's hand hesitate over the propeller pitch levers. The manual dictated maintaining RPM at a minimum of 200 for cruise. Going lower was inviting the thermal spike, the engine death that every instructor had promised. "Now, Dale," Vance commanded. "RPM to 1600. Ranson winced, pulling the levers back. The engine note instantly changed, dropping from a high-pitched whine to a deep, heavy bass rumble. It sounded wrong, laboring. "Manifold pressure to 30 inches of mercury," Vance continued, "and mixture, autoleon." The pilot executed the commands. The combination was the precise definition of oversquare. It was a configuration used, perhaps, for a few seconds during a highly aggressive climb, but never for sustained cruise. The instruments screamed silent warnings. The engine gauges looked like they were lying. The crucial indicators were the cylinder head temperatures, CHT. They were the engine's fever chart. If they climbed past the red line, the test was over. The engine would seize, the plane would be lost, and Vance would face a court-martial for the pilot's death. For the first 30 minutes, the CHT needles held steady. The fuel flow meters, however, told a revolutionary story. "Mr. Vance!" Ranson's voice was tight, a mixture of awe and terror. "We're showing 70 gallons per hour total consumption. That's impossible. We should be burning over 100. Vance's heart pounded. The calculation was correct. At that rate, the P-38's internal fuel alone could sustain a combat radius of over 700 miles, a number previously considered a fantasy, only achievable with the highest capacity external drop tanks. They pushed it further, 3 hours, 4 hours. The CHT needles remained stubbornly stable, contradicting the ingrained dogma of the U.S. Army Air Force. Why? Why wasn't the engine blowing up? "It's the pressure, Dale," Vance explained, watching the fuel flow. "We're using fewer combustion cycles to achieve the same power. Each stroke is more efficient, but crucially, it leaves more time for the heat to dissipate before the next firing. The engine is working smarter, not harder." They flew for 7 hours, far longer than a standard P-38 mission with full combat load. Ranson landed the fighter in the pre-dawn silence. The engine cowl was cool to the touch. The fuel tanks held reserves that should not have existed. The paper report Vance drafted was simple and irrefutable, detailing the exact settings and the new, projected 750-mile combat radius. It was a mathematical blueprint for victory in the Pacific. He submitted it to the USAAF Flight Standards Board. The response was immediate, predictable, and chilling. Vance's data was labeled unrealistic, his methodology unorthodox, and his findings were deemed a dangerous aberration. The report vanished into the system, flagged as CC-407. The military refused to believe that one civilian's meticulous obsession could overturn decades of their established, deeply flawed truth. The secret, however, was now written in the flight log of a borrowed plane, waiting for a desperate commander to find it. May 1944, Hollandia Air Base, Dutch New Guinea. The air was thick with heat, humidity, and the pervasive scent of failure. The 475th Fighter Group, Satan's Angels, was dying a death not by enemy fire, but by distance. Lieutenant Colonel Miles Talon Hayes, the group commander, stood before a wall map covered in grease pencil. His face was gaunt, etched by sleepless nights spent calculating fuel reserves. Their target was Biak Island, a crucial Japanese air hub. The mission required a 950-mile round trip. The P-38J, even with the largest drop tanks, had a reliable combat radius of maybe 570 miles. "We can reach the target, gentlemen," Hayes told his squadron leaders, his voice heavy. "We can hit the target, but we cannot fight for 15 minutes and return with a safe margin. We're losing more good pilots to fuel exhaustion over water than to zeros. And the brass? They keep telling me. The plane performs to specifications, Colonel." Specifications designed in a clean California lab, not over the damn Pacific. Hayes was fighting a war on two fronts, the Japanese in the air and his own supply lines in Washington. He was desperate for a solution. 1 week later, a battered transport plane dropped off a load of high-priority engine spares. Tucked into the bottom of the manifest, almost an oversight, was a single, thin manila envelope addressed to Hayes, stamped, "Internal Lockheed, do not distribute." Inside, Hayes found a copy of the officially suppressed CC-407 report. The paper was creased, a ghost of its original pristine state. It had been smuggled through the chain of command by a disillusioned maintenance officer who had seen the Mojave test logs. The report contained Elijah Vance's heretical theory, the low RPM, high manifold pressure, and lean mixture. Hayes read the part about over square, the guaranteed engine killer. It flew in the face of everything he had been taught since flight school. Adopting these settings was not just unauthorized, it was grounds for court-martial and dereliction of duty if it led to a single fatal engine failure. Hayes walked out to the line. He looked at his crews, young men, already pushed to the physical limit by 7-hour missions in the cramped P-38 cockpit. He thought of Captain Miller, lost 2 weeks ago, not to a zero, but to a sudden headwind that ate his last gallons 30 miles from the runway. He called his operations officer, Captain Donahue, into his hut. Hayes didn't mention Vance, or Lockheed, or the civilian who wrote the report. He simply pointed to the numbers. "We're changing the flight manual, Captain," Hayes said, his gaze fixed on the wall map, not his officer. "Starting tomorrow, the 432nd Squadron will implement cruise setting Canyon, RPM at 1600, manifold pressure at 30, auto lean mixture. We are flying a 3-hour range test to a point 300 miles past our current envelope." Donahue stared, aghast. "Colonel, that's impossible. That's over square. The engines will detonate. It's what we teach them to avoid." "Then we'll unteach them," Hayes clipped. "The official manual is killing us slowly. The only way to survive is to do what they call impossible. If it works, we win the war in this sector. If it fails, I take the blame. You log this as an experimental high-altitude performance trial. No mention of fuel, no mention of range." The choice was made. Hayes had embraced the technical heresy, The 475th Fighter Group was now engaged in a secret war within a war, staking their very existence on the calculations of a civilian prophet they had never met. The fate of MacArthur's push toward the Philippines now hung on the fine-tuning of two temperamental Allison Virod 1710 engines at the edge of the thermal envelope. June 29, 1944, Hollandia Air Base. The mood on the flight line of the 482nd Squadron was one of tense, controlled paranoia. The first flight, using the new unauthorized canyon settings, had launched at dawn. 4 P-38J Lightnings, led by Major Donahue, flying the deepest armed reconnaissance route ever attempted by the group. They were chasing a phantom target, a distant supply depot the brass insisted was unreachable. Ground crews waited, their eyes locked on the horizon. They were maintenance men. They lived by the numbers. And every number they knew said that after 7 hours, those 4 Lightnings should be running on vapor, if they were still airborne at all. At 7 hours and 45 minutes, the 4 silhouettes appeared, impossibly small dots growing rapidly into the familiar, twin-boom shape of the Lightning. They landed smoothly. The pilots taxied back, their faces grim, exhausted not from combat, but from the relentless, monotonous pressure of 8 hours in the claustrophobic cockpit, waiting for the Allison engines to die. But the engines hadn't died. They hadn't even coughed. The crew chiefs rushed to the aircraft. The standard procedure was to dip the tanks immediately. The first chief to check Donahue's P-38 froze, staring at the fuel gauge and then at the dipstick. He checked the gauge again, tapping it sharply. 210 gallons remaining. A collective, silent shock ran through the ground crews. 210 gallons was enough for over 3 hours of additional cruise time. On a mission that was supposed to have killed the engines entirely, they had returned with a quarter of their total capacity. It was a statistical impossibility. The paradox of the fuel gauge began immediately. Pilots who had flown the mission, having meticulously monitored the consumption rates which contradicted all their training, found themselves unable to reconcile the fact with their ingrained fear. "I kept waiting for the thermal spike, Colonel," Major Donahue reported to Hayes that evening. "The CHT gauges barely moved. They actually ran cooler than at standard cruise RPM. It's like flying a different airplane. But every instinct I have tells me I should be swimming right now." Hayes looked at the numbers, his heart quieted by the sheer, undeniable reality of the math. The P-38's effective combat radius, which had paralyzed their deep strike efforts, had just jumped from 570 miles to over 750 miles. A 31% increase achieved not by installing new engines, but by challenging a flawed rule. Word spread, fueled by whispers, not official reports. The 475th became the Ghost Group. They were suddenly appearing over Japanese targets previously considered untouchable, their fighters full of fight and full of fuel. The psychological effect on the pilots was revolutionary. The feeling of running on empty was replaced by a sense of invincibility. Hayes knew he now commanded the only squadron in the Pacific whose range was governed by science, not superstition. But his problem had also magnified. He couldn't keep this miracle localized. He had to convince the rest of the 5th Air Force brass to embrace the heresy of the lean mixture and the low RPM. And he had to do it before the engines, pushed to their technical limit by Elijah Vance's forgotten method, failed in a way that would allow the official doctrine and the man who had created the fix to finally bury the truth forever. August 1944, Rabaul Airfield, New Britain. The war in the Pacific was defined by attrition, but in the air, it was often defined by the absolute limits of aviation engineering. For the Japanese High Command, the P-38 Lightning had a known, manageable flaw: distance. They tracked its operational range with meticulous, cynical precision. When the Lightnings appeared, they knew they had mere minutes before the American fighters had to commit to combat or turn home, always flying on the knife edge of fuel exhaustion. This calculated confidence was shattered by the Ghost Group, the pilots of the 475th, now routinely flying missions 200 miles deeper than ever before. In a makeshift intelligence bunker, Admiral Fukudome, commander of the Japanese 4th Air Army, reviewed mission reports. He stared at a damage assessment over Wewak, a target that should have been hit only by heavy bombers, not escort fighters. The Shikis, Japanese interceptors, reported sustained combat for 20 minutes, his chief of staff reported, his voice tight. When the P-38s finally disengaged, they flew away at high speed, without panic. They were not running on fumes, Admiral. This is impossible. We estimate their previous limit was 950 kilometers out and back. These reports put them at 320 kilometers. Fukudome slammed his fist onto the map. They have deployed the Super Lightning, a new engine, a new fighter. The idea of a radical American technological leap was more palatable than the reality that the Americans had merely changed a number. The confusion was magnified by a rare, almost unprecedented development: the presence of a German Luftwaffe consultant, Oberleutnant Erich Kellner, a highly decorated former fighter ace reassigned to the Pacific to advise on high-altitude tactics. Kellner had accounted for over a dozen P-38s in North Africa and the Mediterranean. He knew the twin-boom fighter's temperament and its vulnerabilities. In early September, Kellner flew a patrol in a captured, modified Zero near the perimeter of the 475th's operational zone. His objective? Test the limits of the American long-range escort fighters. He found a lone P-38 on reconnaissance, an easy kill, typically exhausted and slow on the return leg. Kellner, flying at a high Mach number, executed a perfect dive-and-zoom attack, the classic hit-and-run tactic against the perceived slow-turning P-38. The Lightning pilot, Captain Smith, one of Hayes's converts, saw the Zero coming, but instead of running, he performed an unexpected maneuver. He held his altitude, pushed the nose down slightly, and relied on the new, efficient canyon power setting. Kellner expected the P-38 to wallow, heavy with its presumed drop tanks, its pilot eager to conserve the last drops of fuel. Instead, the Lightning accelerated with a smooth, relentless energy, its engine singing the deep, quiet rhythm of the low RPM cruise. It flew away from him, effortlessly maintaining a speed and distance that should have drained its tanks dry. Kellner could not close the gap. The German ace, an expert hunter, was forced to break off, his frustration turning to cold professional dread. He landed back at Rabaul and filed a chilling report that confirmed Fukudome's worst fears. "The American P-38 is no longer the machine we catalogued," Kellner wrote in his German-language summary, which would later be recovered by Allied forces. "It exhibits a sustained endurance previously considered impossible for a liquid-cooled engine of that generation. Its pilot demonstrated no anxiety regarding fuel. It has been made untouchable. We must assume the USAAF has integrated a radical, unseen technological advance." The official consensus among the Axis was fixed. The P-38's flaw had been eliminated by a hardware upgrade, a secret new engine. The true, simple, and embarrassing reality, that it was a civilian's mathematical trick, remained buried, and this institutional misdiagnosis by the enemy would now buy Colonel Hayes and Eli Vance's method the crucial time it needed to spread. 1999, Dr. Elias Thorne's home office, Maryland. The historian was surrounded by digitized microfilm and enlarged scans of archive maintenance logs. He had solved the first half of the mystery. Eli Vance's mathematical trick of low RPM and high manifold pressure provided the range. But the second half, the safety element, remained a chilling anomaly. Why, despite the universal military dogma, did the engines not detonate? Why did the cylinder head temperatures, CHT readings, come back cooler than standard cruise? Thorne found his answer hidden deep within the non-standard paperwork of the 475th. It wasn't in a formal report, but in the mundane, handwritten notes of Master Sergeant Roy Hess, a crew chief assigned to Lieutenant Colonel Hayes's personal aircraft. Hess kept a meticulous, unauthorized diary detailing every unusual repair. Thorne focused on Hess's entries from early June 1944, just before the canyon settings were adopted. The entries described a peculiar, low-priority job on the engine nacelles. Hess detailed the installation of a non-standard, locally fabricated aluminum spacer, a piece of metal less than half an inch thick, inserted into the mechanism controlling the oil radiator flap. The official P-38 cooling system was complex, relying on radiator flaps to manage the heat generated by the liquid-cooled Allison engine. The flaps were usually either fully open for high power or moderately closed for cruise. Hess's note was concise and initially meaningless. Installed Vance spec limit pin on oil flap linkage. Restricts minimum travel by 0.375 inches. Said it was for uniform flow calibration. Thorne felt a sudden electric realization. It wasn't about the oil's cooling. It was about the intercooler bypass. The Allison V1710 used an intercooler to chill the compressed air before it entered the engine. This was crucial because cooler air meant denser air, which prevented the premature ignition or detonation that caused the CHT spike. By forcing the oil radiator flap to remain open just that tiny fraction, 3/8 of an inch, Vance wasn't solely optimizing oil cooling. He was subtly, yet dramatically, changing the airflow balance across the entire twin-boom nacelle. This minute alteration created a barely perceptible vacuum effect that slightly increased the efficiency of the intercooler bypass system and, critically, diverted a minuscule but perfect amount of boundary layer air over the cylinder heads. The heat signature. Fix. The low RPM, high-pressure cruise created the potential for destructive heat, but Eli Vance's tiny, fabricated spacer bled the heat away just as fast as it was generated. It was a mechanical safety valve, a physical countermeasure to his own mathematical heresy. Thorne had the full picture now. The Lightning's extended range wasn't just a pilot technique. It was a dual innovation. The formula, the over-square cruise settings, the impossible math. The fix, the 0.375-inch spacer, the invisible safety. The official USAAF report only mentioned the pilot settings, making it look like a pure operational discovery. The physical modification, the genius from the workshop, was deliberately obscured within the mountains of routine maintenance reports. Vance hadn't just taught them how to fly the P-38 longer. He had physically prevented the engine from self-destructing when they did. He had given the pilots an untouchable machine, and the military had buried the inventor's tiny, life-saving secret. October 1944, War Department, Washington, D.C. The success of the canyon setting, now informally known across the Pacific as the Hayes method, could no longer be ignored. Reports were flooding the Pentagon. Missions to Mindanao, deep strikes into the Dutch East Indies, and long-range escorts where P-38s arrived and departed with nonchalant fuel reserves. The 31% increase in combat radius had become a strategic necessity for General MacArthur's advance. But the success brought a crisis. The senior command of the Army Air Forces, USAAF, faced an untenable political truth. The single most critical performance upgrade to their premier twin-engine fighter had been achieved by an eccentric civilian, using settings that directly contradicted 2 decades of official USAAF and Lockheed training manuals. To publicly admit this would be to acknowledge that the entire flight standards establishment, the generals, the senior engineers, and the training staff, had been fundamentally wrong. The political risk was judged too high. General Hoyt S. Vandenberg, then a rising star in Air Force leadership, initiated the operation to sanitize the record. This was not a security measure against the enemy. They already assumed a hardware upgrade. This was a censor effort against history itself. The orders were clinical and precise. The technique must be adopted. The canyon settings, 1600 RPM, 30 CU, HG, Autolean, were to be incorporated immediately into an addendum to P-38 Flight Manual, N0125FF1. It would be presented as a late-stage optimization discovered by experienced field commanders. The civilian must be erased. Civilian consultant Eli Vance, CC-407, was abruptly relieved of all duties and barred from any military installations. His original report, the Mojave test logs, and all references to his name regarding P-38 engine parameters were to be purged from classified and technical review archives. The physical proof must be obscured. The simple, ingenious 0.375-inch spacer, the mechanical safeguard that made the lean mixture setting safe, was quietly introduced into the assembly line of P-38L production models. It was logged under a generic part number, disguised as a minor cooling system tolerance adjustment, with no reference to its true function, preventing thermal runaway. The memo Thorne would later discover, consultant file CC-407 status, permanently closed, was signed in this era. It wasn't the signature of a spy master, but of a general concerned with institutional face. Eli Vance, the man who had given the P-38 its wings, vanished. He returned to obscurity, his career finished, having signed a mandatory, legally binding non-disclosure agreement that ensured he would never claim credit for his invention. He became a non-person, his genius officially reattributed to the system that had initially condemned it as sabotage. The P-38 Lightning, the fighter that had just gained its crucial long-distance capability and would now escort bombers all the way to the Philippines, became the silent beneficiary of a perfect lie. The pilots knew Lieutenant Colonel Hayes had broken the rules and saved them, but few, if any, knew the man who had given Hayes the terrifying, brilliant numbers. The fact they tried to erase from the archives was the genius from the workshop, a civilian who saved thousands of airmen but couldn't save his own legacy. 2018, a private high-resolution digital imaging lab, Houston, Texas. Dr. Elias Thorne, now 86, sat before a massive monitor. His retirement savings poured into the final, desperate stage of his decades-long investigation. He was no longer relying on paper. He was relying on light and physics. Thorne had acquired dozens of high-resolution scans of aerial reconnaissance photographs taken over New Guinea between late July and November 1944. These were not the sleek official publicity shots, but the grainy, chaotic overhead pictures taken by accompanying photo reconnaissance lightnings, often capturing their own escort fighters mid-flight. His goal, to prove the existence of Eli Vance's tiny physical fix, the 0.375-inch spacer that altered the oil radiator flap's closed position. This was impossible by visual standards. The alteration was too small, too localized within the nacelle, to be visible from a distance of 1,000 feet. But Thorne was using a cutting-edge technique called thermal spectral analysis, TSA, a process that could infer minute physical changes based on heat dissipation patterns captured by the orthochromatic film of the era. The breakthrough came with a photograph taken in October 1944, showing a flight of P-38Js returning from a deep strike. The aircraft were flying in the canyon cruise setting, low RPM, high manifold pressure. Focus on the inboard boom, left engine, Thorne instructed the technician. The technician isolated the boom and ran the spectral analysis algorithm. The resulting digital model revealed a heat map of the engine nacelle. According to the original Lockheed thermal profiles, a P-38 cruising at 30 inches of manifold pressure should show a distinct hotspot over the cylinder banks, evidence of the thermal stress caused by the lean mixture and low fan speed. This was the spot that should have caused detonation. The model showed the opposite. The area over the cylinder heads on the lightnings of the 475th, the group that first adopted Vance's method, registered a uniform, slightly lower heat signature than surrounding areas, creating an almost perfect thermal equilibrium. The heat was not allowed to build. It was being actively managed. Thorne leaned in, pointing at the digitized image of the oil radiator flap. There, the physics proved the hardware change. Because the flap was held open by the subtle, mandatory spacer, the airflow was channeled more efficiently, creating an invisible, protective air curtain over the engine's hottest components. The engine could run in the over-square configuration without risk because Eli Vance had pre-cooled the detonation zone. The data was irrefutable. The P-38's revolutionary range increase was not solely due to the pilot's technique, nor was it due to an official, factory-designed cooling upgrade. It was due to a fractional mechanical adjustment, the genius from the workshop, that quietly eliminated the P-38's single most dangerous thermodynamic flaw. Thorne realized the cruelty of the cover-up. By only adopting Vance's settings publicly and hiding his physical fix, the USAAF had maintained the fiction that their engineers knew best. They took the life-saving innovation and attributed it to field experience, ensuring that the true inventor remained a ghost, his secret only visible decades later through the detached, objective lens of modern science. The Lightning with no weaknesses was built on an invisible 0.375-inch lie. 2019, Dr. Elias Thorne's study. The historian held the complete narrative in his hands. The redacted memo, the pilot's testimony, the mechanic's diary, and the definitive thermal analysis. He had proven that Eli Vance, the civilian consultant, had not only solved the P-38's fatal range flaw, but had been systematically erased by the institution he saved. Thorne lacked only one piece of the puzzle: the direct, documented motive for the high-level censorship. Why the visceral need to erase a national hero? The answer came not from an archive, but from a private funeral in Virginia. Thorne attended the service for a man named Howard Sterling, a former USAAF colonel who, in the 1950s, had served as an aide to General Vandenberg. Sterling's son, after finding Thorne's decade-old articles about the P-38 anomaly, handed the historian a single, sealed, water-stained envelope labeled, "After my death only." Inside was a short, 2-page, unsigned deathbed confession, dictated by Sterling 20 years prior. The text was blunt, cutting through the bureaucratic language of the war machine. The decision to shutter CC-407 was political, not technical. Vance's method was too effective, too simple. It proved that 2 years of USAAF flight doctrine and hundreds of hours of pilot training were based on a misunderstanding of thermodynamics. General Vandenberg made the call. To admit the P-38's performance was saved by a non-military outsider using a technique previously labeled dangerous would have discredited the entire command structure. It would have created a public scandal, undermining faith in the official doctrine at a time when Roosevelt needed every ounce of confidence to fund the war effort. Vance was a threat to institutional ego. We chose to save the reputation of the USAAF over the man who saved the P-38. We incorporated his genius as our own field-discovered optimization. He wasn't a soldier, but his ideas saved thousands of airmen. We paid him for his silence and let history forget him. The final document was Thorne's shock and final confirmation. The story of the Untouchable Lightning was not about a technical breakthrough. It was about betrayal and silence. The invention that made American pilots feel invincible for the first time was born of a mathematical heresy, executed in secret and then deliberately stolen. Eli Vance, the prophet in the factory, the man who dared to challenge the dogma of over square, gave his country a strategic advantage worth dozens of divisions. He doubled the combat range of the P-38, ensuring air superiority over the vast Pacific and enabling MacArthur's rapid push toward the Philippines. He wasn't a soldier, but his idea saved thousands of airmen. Thorne closed the file. The military succeeded in its cover-up for 75 years. But the truth, the historian realized, never truly dies. It simply waits in the darkest corners of the archive, preserved in the faint ink of a mechanic's diary, or visible only when illuminated by the light of modern physics. The real lesson was the quiet, brutal mechanism by which history is written. The institution always wins. The great technical victory was secured, but the cost was the erasure of the genius responsible. The impossible became routine, and the civilian who made it so became nothing. He was the ghost in the machine, the true pilot of the P-38, the man who made it truly untouchable.